Okay, we are going to graph absolute values, and we're going to be stretching, shifting them vertically and horizontally, etc. So we're going to discuss, I just discussed with the class what the y equals the absolute value of x looks like, which is the same as f of x equals the absolute value of x. And we discovered it makes a v. The basic absolute value graph cuts the first and second quadrants directly in half. Okay, it has a vertex, if you will, at 0, 0. So vertex here for this one would be 0, 0. All other absolute value graphs are derivations of this one, or stretches of this one, or flattening of this one, and shifting to the up, down, right, or left. So this is the format. We talked about circles yesterday where the center was HK. This time now, the vertex is going to be HK. It's going to be the horizontal shift H and the vertical shift K. Now notice on the circles we had minus H and minus K in the problem. Well, that's because the Y and the X were both on the left, right? You remember how it was that quantity X minus H quantity squared plus Y minus K quantity squared equals R squared? Both the Y's and the X's were on the same side. Well, they're not this time. This is like your Y, okay? So that's why it's plus K. All right, so what we have to remember is this would be a horizontal shift for H. That is it shifts the vertex. I'm going to go ahead and start writing that down since I'm talking about it. Shifts now it's kind of like vertex in quotations because it's not really a true vertex. Vertexes are on your parabolas, but it shifts the vertex right or left. That's what H does. And that would be horizontally. You need to think the wording horizontally right or left. So what would K do? Well, that's going to shift it. Shifts your vertex again. Up or down, which you might say, well, obviously up or down is vertically. I do want you to get used to saying vertically and horizontally, though. Okay, so that would be vertically. Vertically. Let's say it weird. Now, this one opened up the regular basic absolute value graph. I'm starting to say parabola. It opened up because it was just one absolute value of x, if you will. This one has a 2 in front of it, and that's called the a value in the format. Remember, f of x is just like y. The a does something to the y values because you see how h will shift. Okay, see where the h is? It's by the x. X-axis is the horizontal axis. That's why it's a shift right or left. It's affecting x, okay, the shift of the horizontal numbers. All right. K is outside of the absolute value bars, and it's a vertical shift. A is also going to affect the y values, and it's just going to multiply them, so it's going to make them either go up faster or slower. Okay, so what does and A also determines whether it opens up or down. So it's going to open up if A is positive. Oh, I should have put the letter A because it's not there. Opens up if A is positive. Therefore, if it opens down, that's when A is negative. That reflects the graph over the x-axis. So it's a reflection in the x-axis. Okay, the vertex for this particular one, we'll talk, A. Up here, A is, it stretches or flattens it. It stretches or flattens the V. Okay, and HK is the vertex, which is usually it's a bottom or top of the V. All right, so let's check this graph out. If you wanted to graph this particular one, it's got an A of 2. It's got a vertex of HK, which would be not, it says +1, and the format says -H. So what is H? Yeah, it's the opposite of what you see, so it's going to be -1, and the K is 3. So you would go to -1, 3, and the A value, we're going to use that. We're going to use as a slope of the right branch. So if we get to use that as a slope of the right branch, I'm going back here to my -1, 3. I'm going to go up to right 1 and make a point. Up to right 1, and I'm going to keep going. I don't want stubby graphs. That's the right branch of your absolute value graph. The left branch, we're going to do not 100% the opposite of, you know how when we graphed a line, you can go to the y-intercept and you can go up to right 1, up to right 1, or you can go down to left 1, which is 100% the opposite. That's reversing the top and the bottom number, which makes it the same sign. Okay, we don't want to do that now. For the left branch, we want to find the other part of the V. So instead of up to right 1, we're just going to say up to left 1. Okay, and now we've graphed it, although I didn't hit my points very well. All right, that's our V. Now notice that if I looked at these, again, the vertex or the shift, remember how I talked about H shifts it right or left? H went, so the normal vertex, which is normally at 0, 0 of the absolute value of X, we went left 1, up 3. Okay, so that's the shift. It would be left horizontally 1, up vertically 3. Okay, let's try some more. So just before we do that, this is just basically what I just went over. We call this the parent graph. It's like what everything else is based on. So like for a parabola, which we did do some graphing of, the parent graph is y equals x squared. Okay. For a line, y equals x. It's just that would be a parent graph. For this absolute value, then you take and you do stuff to the parent graph. A again. It has a vertex HK. It has, oh, by the way, there's symmetry in the line x equals h. Let me show you what that meant on the last graph. There's symmetry on this line right here, this vertical line where x equals h. That's a vertical line at -1. So that would cut that V in half. That's why it has the matching branches. Okay, the graph is V-shaped. It opens up a phase positive, down a phase negative. It's wider than the parent function if it's between 0 and 1, which the absolute value would mean between 0 and 1. That's when it's a fraction, like 1/2, 1/3, something like that. That's going to flatten the graph out. If A is bigger than 1, it's going to make it skinnier. Okay, so that 2 that we just graphed, when we did an A value of 2, it made this V stretch faster, higher. So it's not as flat as this one. Okay. All right, so let's see what happens when we graph some more. I'm not going to graph all of these. I'm going to graph just a few. So I'm going to do number 2. Just because that's my basic graph flipped over. All right, the negative sign changes all the y values to negative values. The values that you stick in for x are all still positive, but once you pull them out, the y's are negative. So if you put in 0, you get 0. I guess I'll use red. Okay, so here A is -1. All right, so 0, 0 would be your vertex because H and K, and it says to list the vertex and the domain and the range. So 0, 0 is my vertex. I go to 0, 0, and then I take to do the right branch. I use the slope, -1, down 1, right 1, down 1, right 1, and I keep going, which will cut the fourth quadrant in half. Right down the middle. Then I reverse that and I do the left branch, bless you, by going down one, left one, down one, left one. So the right branch, down and right, left branch, down and left. Okay. The domain for this is negative infinity to infinity. You get to put in any x value you want. And the range, though, is restricted. Remember, you have to go small to large when naming the range. If it keeps going down forever, then you are going towards negative infinity. So the range has to start with negative infinity up to stopping at 0. Does it include 0? Well, the 0.00 is on there, bless you, yes. So, inclusive. Number 3, that would, well, let's not do number, well, I'll do one more of those. Okay, let's do number 3. The vertex would be at, H is 3, K, there's nothing out there, so it must have been 0. The A value is 1. Okay, so I'm going to plot the vertex at 3, 0, which is on the x-axis. It's a shift of this graph, the regular parent graph of right 3. Up 1, right 1, up 1, right 1, and just keep doing that for the right branch. Up 1, left 1, up 1, left 1 for the left branch. Tennis? Good luck. All right, there's the right branch and there's the left branch. All right, I'm not doing the next one. So let's move on. I'm going to leave those to you. Oh, let's finish the domain and range. I wrote the vertex up there. The domain of this one's still negative infinity to infinity. What do you think the domain is? Domain is for all absolute value graphs. Negative infinity to infinity. Yeah, it is negative infinity to infinity. You got to look at your range, though, for everyone. So this has got a range that's starting at 0 and going up, 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 and beyond to infinity. So it'd be inclusive 0 up to infinity. Okay, I'm going to skip and do, I don't know, let's see. Let's go do something that has more to it, like number 9. Unless somebody wants to pick one before that, I don't. All right, so please stay together here, and let's do number 9. The vertex of this one is going to be at 0, 1. So I go to 0, 1 on the y-axis. The a value is negative 2. Treat it like a slope. Go down to right 1, down to right 1. And make as many as you can fit. That's your right branch. Okay, then go down to left 1 for the left branch. And that's the graph of that one. The domain is still negative infinity to infinity. The range is negative infinity up to, what do we stop at? A y of 1. Inclusive. Okay, now last example, and then I'm going to go over to worksheet 4 in a moment. Yeah, let's do 10. Y equals 1/2 absolute value of x plus 1 minus 3. So the vertex is at negative 1, negative 3. Left 1 down 3, there's your vertex. A is 1/2. Up 1, right 2. For the right branch, keep going till you can't go anymore. That really flattens out the graph. The V is not as VE. It is flatter. Up 1, left 2. And there's the other side. Okay, make sure you're covering the whole grid. domain is still negative infinity to infinity. And the range, though, is, what's the low point? You can see it's the y value of the vertex. So that would be -3 inclusive and up, 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 and away to infinity. Okay, let's look on the back. Does anybody spot one they want me to do? Because I'm willing to do one more of these. Let's see, because that's this part. Your assignment is going to be to complete these. Probably okay? I'll see if you want me to do another one in a little while. So let's go to worksheet 4, please. Okay, so with the other class I did, why isn't this erasing? I need to open a new one. A fresh page 4. Not liking me. No, that's not it. 4, 4, there it is. Okay, if you understood what we were just doing, now we're going to go in reverse. We're going to start with the picture and write the equation. All right, so you may wish to write down the format. Well, there it is. Format's right there. We need to figure out A, H, and K. So, not too hard. Find your vertex. It's labeled at -8, 0. Actually, let's do number 3 together because there's a mess up on that one. The vertex here is 0, 5. That means H is 0, K is 5. You already got 2 of the things you need to fill in. What else will we need to fill in? A, which is we get to use like a slope, so we got to figure out a slope of this side. Does anybody notice a problem here? Is that the right point? Is this X 12, 17? Well, no, it's really not. It's at 6, 11. All right, so we need to fix that. So now that we fixed that, let's do it. Okay, so we need, and we're going to write f of x equals, not y. I mean, not that I would probably mark it wrong, but I'm trying to get you used to function notation. F of x equals, all right, let's figure out a. So you have 2 choices. You can look at the points and calculate the slope, which is the change in y over the change in x. So what's the change in y going from 5 to 11? Up 6? What's the change in x going from 0 to 6? Up 6. So the slope is 1, and it should be positive because this thing's opening 1 up. You could have done the same thing by counting, right? Up 6, right 6. All right, so slope is 1. So that means 1 times the absolute value of, and you don't have to write the 1, x minus the h. Oh, the h is a 0, so I should just close up my bars. Plus 5. And that's the end of that equation. Let's do a completely different one. All right, whatever. I'll just pick 2, and then I'll do one that's got more stuff to it. All right, back up to 2 a second. The vertex HK is 6, 0. So H is 6, K is 0, and then I need to figure out A. You can say change in Y's, 0 to 4 would be 4. 6 to 14 is a change of 8. So 4 over 8 is equal to 1/2. So A is 1/2. So this one's equation, f of x equals 1/2, the absolute value of x minus 6, close the absolute value, and there's no, the K is 0, so you have nothing. You don't want to write plus 0. I would, if you don't simplify, it's going to bother me. So it needs to be simplified, so I just stop. Good. All right, let's try one that looks harder. Someone want to pick one? How about shifting it upside down? 7. Oh, 8? Yeah, let's go for 8. Alex, I can go back and do another one if you want. I heard 8. I heard 7, but I'm doing 8. Okay. Vertex is at negative 10, 8. That's H and K. H is negative 10, K is 8. I need to calculate the slope of the right branch. It is down something. If you look at 8 to negative 2, that would be down 10, so negative 10. You with me how I'm getting that? From 8 to negative 2 would be 8 to get here and 2 more down, so it's down 10. And then right from negative 10 to negative 8 is just over 2. Good? That gives me an A value of negative 5. All right, so our equation is going to be f of x is equal to negative 5 times the absolute value of x, and then you say minus my h. My h is negative 10, so I'm going to write plus 10, close the bars, and plus 8 for the k. Not too bad. So you want to pick one more? You are going to be finishing worksheets 3 and 4 for your assignment, no book assignment. You want to do, I don't care, 10 or 11 or? No one wants to pick? Well, that's just more practice. Okay, well, if you feel like you're good for now, I'm going to stop. I think I did what we need to do, and then you can ask me, or if you want to just check some answers, just raise your hand or tell me. Call me over.